Hello, my name is Stephen Richardson, and the title of my project is Carbon Cycling Within Small Impoundments in a Changing Landscape. And this was conducted within Wake County, North Carolina. My research question was wanted to look at how land cover can affect the water quality that we find within these small impoundments. And if the results are promising, we hope to be able to upscale this to either a regional or national scale. So basically, wanted to look at the spatial relationship of a specific buffer around these impoundments and how the land class can ultimately affect the water quality with respect to carbon isotopic composition in these systems, as the coverage can give indication as to source material, whether produced in system or transported from the terrain surrounding them. So the data that we used, we had two Sentinel-2 images from USGS Earth Explorer, as well as two shapefiles from Wake County government, to include the Wake County outline and major hydrology polygons. And also we had the NLCD data from the most recent set in 2016 from the MRLC. So a little bit of the methodology here. Over this past summer, we investigated 12 different sites for both chemical and optical properties, and performed in laboratory here on main campus, but wanted to kind of revert back to look at the land cover over the same period of time to see how some of the different classifications can drive the chemical properties in these systems. I performed a supervised classification from both of the Sentinel-2 images, and then compared that with the NLCD classification surrounding these 12 water bodies. And the classes that were formed were water, forested, herbaceous, agricultural, and then developed and barren. So a little bit of operational flow here. The first few steps were to obtain the appropriate data that we needed, and then import them into ArcPro. And once the Sentinel-2 imagery was imported, wanted to create band composites within ArcPro of the appropriate bands being 2, 3, 4, and 8, since it is Sentinel-2 imagery. Since they were two separate images, wanted to create a mosaic so it would be one comprehensive image rather than two separate ones. And then from there, created the training samples and performed the supervised classification. And then we really dialed it down to create the buffers around the applicable water bodies, and then extracted by mask both the NLCD and the supervised classifications. And then from there, in the attribute tables, wanted to create a new column to calculate the percentage of class coverage for each one of these. So moving to the results here, the leftmost two images are going to be the supervised classification results, and then dialed down to the applicable buffers around the 12 sites that were investigated. And then the right two images include the NLCD classification, and then again, dialed down to the applicable buffer around the 12 sites of interest. So looking at some of the percentage of coverage, we see there is some variation between the two. Most notably, probably the developed, which has a standard deviation of 21.6, followed by herbaceous at 11.81, and then finally forested that had a 9.90 standard deviation, with the water and the barren coverage being the most agreeable between the two. So really, in conclusion, while there was variance between the two classifications, I think at this point, higher credence can be assigned to the NLCD data, since that's probably proved a little more than I was able to do in the time allotted. Moving forward, and then prior to publishing my thesis, hopefully we can go back and reassess some of the training samples, perhaps find better imagery to really dial in to see if there would be higher agreements between the calculated percentage of coverage. And then ultimately, we would like to use this approach to really get a precursory look at some of the water quality, since there's really no remote sensing that can directly measure water quality. But if we have an idea of land use and how that can potentially affect some of the chemical properties that we can see, we really hope that we can upscale that. Thank you for your time.